Good morning, everybody. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kyarpuram, Bengaluru. Today I am going to discuss about first session of Chemical Kinetics, which belongs to third semester BSc, affiliated to Bengaluru North University. In this class, I have to discuss the second order reaction. And under this second order reaction, what you have to discuss, that is called as a learning objectives. The first learning objective is nothing but definition of second order reaction. Therefore, you have to know about that is the meaning of second order reaction. Then after knowing this meaning of the second order reaction, you have to able to know the examples of second order reactions. Third one is characteristics. What are the properties or characteristics of second order reactions? You have to discuss. Next one, derivation of velocity constant of a second order reaction when both concentration of the reactants are same, that is A is equal to B, that you have to derive this equation. And lastly, finally, you have to know about that is the SI unit of second order reaction. And these are nothing but objectives of this first session of chemical kinetics. Now coming to what are the outcomes or session outcomes means after discussing this class or after the completion of this class, what you have known, what the knowledge you gain know, that is called as a session outcomes. And after this completion of this class, you must know about or you have to able to define that is second order reaction, or you must be say about that is the meaning of second order reaction. Then you have to also identify the second order reaction among the so many reactions. And third one is you have to also known about that is a characteristics of second order reaction, and you have to also able to derive the rate constant equation of second order reaction when the concentration of the both reactants are same, that is A equal to B. And you have to also known about SI unit of velocity constant of a second order reaction. After completion of this topic, that this session, you have to know or you have to gain this knowledge. Now before that is starting of this session, what you have already known, that is called as a, what you have already known the knowledge, that is called as a prerequisites. You already know about that is a rate, order and molecularity of the reaction. Now just I have to highlight, just recall it, make revision. Rate is nothing but change in concentration of the reactant in that is a particular interval of time is called that is a rate of the reaction, or that is the decrease in concentration of the reactants in a particular time is called that is a rate of that particular reactants, or increase in the concentration of the product in interval of in specific interval of time is called that is a rate of reaction. Then order of the reaction. Now how do you define that is order of the reaction? The sum of the powers of the concentration terms found in the experimentally rate determined equation is called that is the order of the reaction. If the sum of the powers of the concentration term found in the experimental rate equation is 0, then that is called as a zero order reaction. If it is a 1, it is called as a first order reaction. Then so on. Then molecularity. What is mean by molecularity? The number of molecules participate in the reaction called that is a molecularity of that reaction. Now molecularity may be unimolecular, or that is a unimono, that is a unimolecular reaction, that is bimolecular reaction, termolecular reaction, whatever may be. Therefore the number of reactant molecules participate in the reaction called that is the molecularity of that reaction. Then you have to able to, you already know about how to write the reaction equation. Then suppose A to B formation of C, whatever may be, know How do you write? You have already know this is the writing of a reaction equation. You have also known about that is the example of first order reaction. This is the already you have known about in previous second year. Therefore, you have to able to give the example of first order reaction. Then you have already also known about derivation of velocity constant of first order reaction. You have already learnt in previous second year, and also you have got knowledge, you have already known about some basic concepts of mathematical operations like integration that involved in this session. These are the pre-knowledge, these are the you have already knowledge regarding these points for this session. Therefore, it is called as a prerequisites. Now coming to that is our main that is session is begins with second order reaction. Now how do we define that is a second order reaction? The sum of the powers of the concentration of the reactants found in the experimentally rate determined equation is called that is a second order reaction. Therefore, general definition of that is the order of the reaction is nothing but the sum of the powers of the concentration of reactants found in experimentally rate determined equation is called that is order of the reaction. If it is a 2, then it is called as a second order reaction. If it is 1, it is called as a single order reaction or first order reaction. If it is 0, it is called as a zero order reaction. Now you already know about here the order of the reaction usually that is based on the experimental rate equation. Experimental rate equation is based on that is a mechanism of the reaction, and that is a number of steps found in the reaction, and the rate is always determined on the slowest step. Therefore, the reaction takes place in multi stage or multi steps reaction. The order of the reaction or rate is depends on only slowest steps. Therefore, the rate determining step is very important. Therefore, for defining the second order reaction, the experimental rate equation is very important. Therefore, simply how do we define that is a second order reaction? Means the sum of the powers of the concentration of reactants found in experimentally rate determined equation is called that is a second order reaction. Now coming to that is the examples of second order reaction. Now first one is that is a dissociation of hydroiodic acid. That is a two molecules of the hydroiodic acid undergo dissociation to form that is a hydrogen gas and iodine gas will be liberated. And the experimental rate equation is nothing but it is equal to the product of the rate constant into molar concentration of the HI to the power of 2. Therefore, here the sum of this is the experimental rate equation. Therefore, order is nothing but the power of the concentration terms. No, therefore it is a 2. Hence, it is a second order reaction. Now, suppose second that is the example is nothing but potassium hypochlorite. That is potassium hypochlorite. This is undergo a dissociation to form that is a potassium chlorate plus potassium chloride. Now here three molecules are participate. Therefore, we say that is it is a molecularity will be a 2. But the experimental rate equation only two molecules are participate. Therefore, here in the hydroiodic acid 2 molecules are participate in the reaction. Therefore, order will be a 2, and it is experimental rate equation, and that is theoretical rate equation is same in this example. But here the experimental rate equation and theoretical rate equation is different, because here 3 molecules are participate in the reaction, but the rate is depends on only the concentration of the 2 molecules. Therefore, experimental rate equation is equal to the product of the rate constant into molar concentration of potassium hypochlorite to the power 2. Therefore, this is the power is nothing but 2. Hence, it is called as a second order reaction. Now coming to that is the characteristics of or characters of second order reaction. First character goes to the second order reaction should obey the second order equation, means the sum of the powers of the concentration terms found in the experimental rate determined equation should be a 2, and then only we say that is it is a second order reaction. This is the first character. Second character is nothing but it involves 2 unit concentration of 2 reactants, 2 unit concentration. Suppose we take that is A plus B formation of product. Therefore, A must be a unit concentration and B must be a unit concentration. Means 1 mole of the reactant react with another mole of that is 1 mole of the B reactant and to form that is a product, and hence we say that is it is 1 plus 1 means it is called as a order will be a 2. And the third is nothing but half-life period of a second order reaction is inversely proportional to the initial concentration of the reactant. This is the half-life period of a particular reaction. I will explain later on what is mean by half-life period. Therefore, characteristics of the second order reaction is nothing but half-life period of a second order reaction is inversely proportional to the initial concentration of the reactant. Now coming to that is a derivation of an expression of velocity constant of a second order reaction with concentration of both reactants are same, that is A is equal to B. For that, this is the important question for 4 marks, always that will be appear in the examination. Therefore, how do you derive that is a equation? For that, consider a second order reaction A plus B formation of product. Now here it is the unit concentration of the both reactant A. This is the unit concentration, another unit concentration. 1 plus 1 means it is a 2. Therefore, this can be written as the rate can be determined. Suppose X is the change in the concentration. Therefore, it is called as a dx divided by dt equal to K into the product of the molar concentration of the A into molar concentration of the B. Therefore, sum of the powers of the concentration term means A power is 1 and B power is 1. Therefore, 1 plus 1 means it is 2. Therefore, it is a second order reaction. Now, for that for a derivation we require that is we just simply in the reaction manner you have to write A plus B formation of product, that is same I have written at initial time T is equal to 0. At initial time before reacting, that is A plus B, the time is 0. Therefore, initial concentration of the A is equal to A and initial concentration of the B, that is a reactant B, is equal to B. But in this case, A is equal to B is given. Therefore, this is the initial concentration of small a be the initial concentration of the reactant A and small a be the initial concentration of the reactant B and formation of the product. At 0, there is no product will be there. Therefore, 100% that is a reactant, that is A reactant and B reactant will be present. After time T, means after 5, that is 10 minutes, 50 minutes, whatever may be, or after 1 hour, whatever may be, after some times, the X will be the degree of dissociation, means X will be a decrease in, X will be a changes into product. Therefore, X will be the product. And after that is a time T, remaining concentration. What are the remaining concentration of reactant present in the particular reaction is nothing but after time T, A minus X. X is nothing but it is a formation of the product, that is a decrease in concentration, means that is X will be a decrease. Therefore, A minus X will be the remaining concentration of the A reactant. Similarly, that is A minus X will be the remaining concentration of the reactant B, and X will be the product, that is the concentration of the product in the reaction. This you have to explain. Therefore, we say that is from this the molar concentration of the after time T, molar concentration of the reactant A is equal to A minus X and molar concentration of the reactant B is equal to A minus X. We can write. Otherwise, just in word, suppose you are writing these, this is not required. If you write these, then it should not be right. Therefore, you have to write this. Let us the initial concentration of the both reactants of be the same, that is A is equal to B and equal to a mole per decicubic meter. Decicubic meter. After a interval of time t, let x mole per cubic decimeter of each reactant A and B be the consumed to form a product. Therefore, that is, we say that is after time t, that is a molar concentration of the A is equal to molar concentration of the B is equal to A minus X. The rate of the formation of the product is given in the concentration of the reactant at the instant is. Therefore, this value, A is equal to the molar concentration of A is equal to molar concentration of B is equal to A minus X. That can be put in the, that is equation number 1. Therefore, we get that is a dx divided by dt is equal to k into A minus X into A minus X. Therefore, you have to make that is these are the similar. Therefore, we get that is after simplification dx divided by dt equal to k into A minus X to the power of 2. Here k is nothing but velocity constant or rate constant. Then it make that is a variable separation. A variable separation means x should be that is one side, x one side and other letters should be a other side. Therefore, dx, that is after cross multiplication, dx divided by A minus x square equal to k into dt. Now, to this, taking the integration sign on the both side to this equation. Therefore, integration of dx divided by A minus x square equal to k is the constant actually. Therefore, it should be take outside the integration sign. Therefore, integration of dt. Then you have to modify this equation for our convenience. You make that is a numerator. This is the denominator, no? Denominator is converted into numerator. Therefore, integration of A minus x to the power of minus 2 dx equal to k into dt. Then you take that is a integration. You have to be familiar with that is formula. Integration of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus c. That is the formula. Therefore, apply to this. Therefore, this is say that is a minus n is nothing but minus 2 is nothing but n. Therefore, after taking that is the integration, a minus x to the power of n means minus n minus 2 plus 1 divided by n plus 1 means, therefore we have to minus 2 plus 1, and here you have to take minus sign is the, that is the x. Therefore, you take that is a minus and 1. Minus x is nothing but 1, just taking as the differentiation of this like, no. Therefore, we say that is minus x minus 1 will be there and equal to k as it is, and integration of dt means that is a t and plus that is a c. C is nothing but integrating constant. Here it is arbitrary constant or it is a remains constant in this problem only, and it is a constant. Therefore, it is called as a integrating constant. C is the integrating constant. Now, you must be know about, because it is a indefinite integration. Therefore, it is called as a, you have to put that is a find the c value. Now here you have to find the, our duty to find that is the value of c. See, it is make that is simplified. First, it is you have to make that is this equation is simplify. Minus 2 plus 1 means minus 1. Minus 1 into minus, that will be a plus, and therefore a minus x to the power of minus 1. Therefore, you have to make it is a reciprocal, means it is a comes, that is a denominator 1 divided by a minus x is equal to kt plus c. And this is called equation number 2. Now, our duty to find that is a value of c. At initial reaction when time is that is a time is 0, means before that is a reacting, the time is nothing but 0, and therefore product will be a degree of dissociation or degree of ionization of the reactant or change in concentration of the reactant will be a 0. Therefore, x will be a 0 at time is 0. Then substitute this condition, these values of t and value of x in equation number 2. Then we will get that is equation 2 becomes 1 divided by a as it is, minus x means 0, that is 1 by x, a is became, then equal to k into t is nothing but 0, therefore k into 0 means it should be a 0, plus c is remains as it is, therefore we will get that is a 1 divided by a equal to c. Substitute this value in equation number 2. Therefore, we will get that is a 1 divided by a minus x equal to kt plus 1 divided by a. And this is the equation. Then our duty to find that is the value of k here, because a rate constant is required. T is nothing but time actually. Time of the reaction takes place. Now here k is equal to, just you have to transfer, that is 1 divided by t. Then first you have to transfer, this is the, you have to write that is kt equal to 1 divided by a minus x minus of 1 divided by a. Then you have to transfer next steps, k is equal to, transfer the t, k is equal to, we will get that is a k is equal to 1 over t into 1 divided by a minus x minus of a by, that is 1 by a. Then take the LCM of a minus x and a, therefore a into a minus x is the LCM. Then 1 over t into, that is here you multiplying a to this factor, therefore a divided by a into a minus x minus of, you have to multiply this 1 by a minus x means 1 a minus x divided by a into a minus x. Then you have to take the LCM, that is common factor, that is the LCM. Therefore 1 over t, k is equal to 1 over t into a minus x, that is in, this is the denominator, in numerator a minus, you have to multiply this to this factor by minus value, therefore minus a, this is a minus minus plus, therefore plus will be minus a minus a plus x, therefore minus a and plus a get cancelled, you will get that is x. Therefore the final equation is nothing but k is equal to 1 over t into x divided by a into a minus x, and this equation is called that is a rate constant or velocity constant of a second order reaction when a is equal to b. Then coming to that is a last that is concept, SI unit of velocity constant or rate constant. The velocity constant or rate constant is the same meaning, that is two different words for that is same meaning. Therefore SI unit, what is the SI unit of velocity constant of a second order reaction means, you know that is the second order reaction, k is equal to 1 over t into x into a minus x. Now just you have to substitute the value. The usually the time is expressed, that is the t is expressed in time, therefore it is a time. 1 over t I write, that is a t is nothing but time, and x is nothing but concentration. Again a is nothing but concentration, x is the concentration, concentration minus concentration means another concentration, therefore we can write that is 1 divided by time into concentration divided by concentration into concentration. Now you have to cancel one of the concentration, therefore 1 over time into 1 divided by concentration. But again that is in the SI unit, the time is expressed in terms of seconds, therefore we can write for second time I can write s is nothing but small s is nothing but that is second, and concentration is expressed in terms of mole per cubic decimeter, mole per cubic decimeter. This is the expression of that is concentration. After substituting, then it is make that is these are the denominator there, you have to make it is a numerator, therefore mole is converted into per mole, that is here per cubic decimeter is converted into cubic decimeter, and second per second will be converted, that is second is converted into per second. Therefore SI unit of this rate constant or velocity constant is that is a cubic decimeter per mole per second is the SI unit of velocity constant of a second order reaction. Now so far we have studied about that is all these. First one is definition of the second order reaction, second one is character example of the second order reaction, third one is characteristics of the second order reaction, fourth one is derivation of second order reaction when A is equal to B, and last one is fifth one is SI unit of velocity constant of a second order reaction. Now I will ask some questions. You have to therefore just we have studied this, no, that is what are the recapitulation means what you have studied, that is nothing but definition of the second order reaction, example of second order reaction, characteristics of the second order reaction, derivation of the second order reaction, and SI unit of the second order reaction we have discussed so far in this session. Now I have to ask some question. You have to read carefully and you have to answer the following question, or you have to select the correct choice, correct option among the among that particular option. Now first one is nothing but first question goes to which one is the true for the second order reaction. Which one is the true? Which one is the true means here four options are given. One will be a correct for second order reaction and others will be a false. Now here first one is, first option goes to that is sum of the powers of the concentration terms found in experimental rate equation is 0. This is the first option. Second option, sum of the powers of the concentration terms found in experimental rate equation is fraction. And third C, the option is nothing but sum of the powers of the concentration terms found in experimental rate equation is 1. And D option is nothing but sum of the powers of the concentration terms found in experimental rate equation is 2. Now these are the four options are there for this. Now just I will give that is a 10 seconds for you people. You have to just carefully read carefully and you have to select one option among the four. Okay, now I will tell you what is the option here. The D will be the answer of this question. Now just I have to analyze why the D is the answer of this question. We know that is definition of the second order reaction. The sum of the powers of the concentration term found in the experimental rate equation is 2 is called that is second order reaction. And others know, therefore we say that is D is the option is the correct. And others are not correct means the sum of the powers of the concentration terms found in experimental rate equation is 0 means it should be a zero order reaction. Thus B option is nothing but sum of the powers of the concentration terms found in experimental rate equation is fraction, because therefore it is called as a fraction order of a reaction. And third one, sum of the powers of the concentration terms found in experimental rate equation is 1. Therefore it indicate as this definition is considered to that is a first order reaction. Therefore the D will be answer because the sum of the powers of the concentration terms found in the experimental rate equation is 2. Therefore answer will be a 2. Second question, then the example of the second order reaction. What is the second order reaction? Which one is the second order reaction here? Here two molecules of the HI, the gases HI undergo a dissociation in presence of the gold catalyst. The hydrogen gas and iodine gas will be liberated, and the experimental rate equation is given, that is here K is equal to molar concentration of the HI to the power of 0. So B example is nothing but two molecules of the nitrous oxide undergo a heating to form that is the two molecules of the nitrogen gas and one molecule of that is oxygen gas. And the rate equation is nothing but rate is equal to the K into the molar concentration of N2O, that is called as a nitrous oxide to the power of 2. Now nitrous oxide, it is also called as a laughing gas. No, when it is inhaled in the body, it will be used that is a laugh, or it is laughing will be takes place. and therefore it is also called as a nitric oxide is called as a laughing gas. Then C option is nothing but nitrogen pentoxide. Two molecules of the nitrogen pentoxide in gaseous form undergo heating to form that is 4 molecule of nitrogen dioxide plus 1 molecule of the oxygen gas. And a rate equation, experimental rate equation is it is equal to product of the rate constant into the molar concentration of the nitrous oxide. It is a nitrous oxide to the power 1. Nitrous oxide to the power 1. This indicate as a this is the 1. Therefore last one is D is nothing but none of these. Which one is the second order reaction? I will give that is a 10 seconds for you people. You have to pick the example for second order reaction. Now answer of this question is nothing but that is a B option, because when two molecule of the nitrous oxide undergo heating to form that is 2 molecules of the nitrogen gas and 1 molecule of the oxygen gas. But experimental rate equation, you have to observe that is the experimental rate equation. It is very important. We are not that is consulting these reactions. Whatever maybe reactions are there, but we require for determining the order of the reaction, experimental rate equation is very, very important. When we suppose if based on the experimental rate equation, we have to find out. Otherwise, you unable to find that is the order of the reaction. Here, the sum of the concentration term is 0. Therefore, it should be a 0 order reaction. But it is sum of the concentration terms in experimental rate equation is 2 here. Therefore, this example is the second order reaction. Here only 1, therefore it is an example for that is a first order reaction. And therefore B is the option of that is second order reaction. Next, third question. Which one is odd of the following? Which one is the odd of the following? Therefore, one will be a different, and the 4 options are given here. Out of 4 options, 4 options are correct. Only 1 option is wrong. And therefore, which one is the wrong? What you have to find out. Which one is the odd of the following? Now, A option is half-life period of a second order reaction is directly proportional to the initial concentration of the reactant. Second option is nothing but second order reaction should obey the second order equation. Third is nothing but second order reaction involved 2 unit concentration of the 2 reactants. And D option is half-life period of a second order reaction inversely proportional to the initial concentration of the reactant. Which one is the correct? Now here I will give that is a 10 seconds for you people. You have to recall, we have to find the which one is the correct answer. Now answer for this question will be that is a D, because here half-life period by the characteristics. No, you know that is a characters of that is a second order reaction. These are the 3 characters are there. Second order reaction would be obey the second order equation. Second order reaction involved 2 unit concentration of 2 reactants, and half-life period of a second order reaction is inversely proportional to the initial concentration of the reactant. And these are the 3 that is characteristics of second order reaction. You have already known, you have already studied. But this is the half-life period of a second order reaction is directly proportional to is there. Therefore, this option will be wrong. Here it should be a inversely, means here D will be a correct answer and A is the wrong answer. Therefore, this one is the odd among these, and these are the B, C and D. These are the characters of second order reaction, and A option is the not character of, that is a not property of second order reaction. Next, fourth one is a rate constant of a second order reaction. The expression of rate constant of a second order reaction is The first option is, it is given that is a k is equal to 2.303 divided by t log of a divided by a minus x. B option is k is equal to x by t, and k is equal to C option is 1 by t x divided by a into a minus x, and D is nothing but none of these. Now I will give that is a 10 seconds for you people. You have to check, you have to find which one is the correct answer for this question. Now answer for this question will be a C, because you already learnt about that is a velocity constant of a second order reaction. That is a derived, no? That derived the equation, that is k is equal to 1 over t into a divided by a minus, that is a into a minus x. This equation you have already derived. This is concerned to the second order reaction. First option is wrong. Why? K is equal to 2.303 divided by t log of a divided by a minus x. This is the rate constant equation for first order reaction, and k is equal to x divided by t. This equation is nothing but zero order reaction. Therefore, C must be a answer for this equation. Now last, that is the fifth one. SI unit of velocity constant of a second order reaction. The four options will be given: mole per cubic decimeter per second. That is the first option. Second one is cubic decimeter per mole per second. C option is cubic decimeter per mole second, and D option is mole per cubic decimeter second. These are the four options are given, which you have to select which one is the correct answer. For it is concerned to SI unit of velocity constant or rate constant of a second order reaction. I will give again, that is 10 seconds for you people. You have to find the correct answer or choose the correct option among the following. Now answer for this question is nothing but B option, that is a cubic decimeter per mole per second. This is the option. Why? Because the rate constant you already know. Rate constant is equal to 1 divided by t, no? 1 divided by t into 1 divided by concentration. Concentration, that is the time, is nothing but expressed in terms of second. Therefore per time, therefore per second will be there. Time is expressed in terms of second, therefore per second will be there. And next, that is concentration is expressed in terms of mole per cubic decimeter, and therefore it is making that is a numerator. Therefore it became a per mole cubic decimeter. This is the option of. Therefore the unit of SI unit of velocity constant or rate constant of a second order reaction is nothing but cubic decimeter per mole per second is the SI unit. And now I have referred that for this session I have referred these books. These are the reference books. This is a textbook, and these are the others are reference book for preparation of this session. Thank you.